In this video, we will be looking at a problem that involves continuous compounding. We need to use the formula A equals P times E raised to the RT for a continuous compounding problem. Again, the A is your future value, which is the amount in the account after T years. Your P is the present value, or sometimes called principal, and that's the amount that you're depositing right now. E is a constant. It's an irrational number, like pi is an irrational number, only the value of E is about 2.7182818, etc. R is our annual interest rate. We need to write that as a decimal. And then T is our time in years. If you're looking for E on the calculator, some calculators have a special button just for E. On this calculator, it's right above the ln button in yellow there, e to the x. So I could retrieve that value. I need to press Shift and then the ln button, and there's my little e, but I need to raise that to the first power, and so 2.718281828. Now it doesn't repeat that. That looks like it might repeat 18281828, but it doesn't. Now on this calculator, we have our e to the x again right above the ln button, but we would need to press our exponent first if we wanted to see the value. So on this calculator we would press the 1 and then second e to the x and get our value. So the problem that we'll be working is, suppose $8,000 is deposited in an account paying 5% interest, compounded continuously. Now this is the word you want to look for that will tell you if you're going to use this formula or the compound interest formula. So continuously, that tells us that we need to use this formula. And it's compounded continuously for 6 years. We want to find the total amount in the account at the end of 6 years. So let me write the variables A, P. We don't need to write E because we know what that is. That's a number that we'll use from the calculator. R and T. Suppose $8,000 is deposited. So the amount deposited is our present value. So the P in the formula is going to be $8,000. Paying 5% interest. So our rate, 5%, we need to write that as a decimal. We need to move this 2 places to the left. So one place would move it to 0.5, and then we'll have to annex a 0 out in front here. So we'll have 0.05 as our decimal for the R value. Interest compounded continuously for 6 years. Time is 6. And we want to find the total amount in the account at the end of 6 years. So this A value is what we're looking for. So now let's write our formula. A, we don't know that, so we'll leave it as a variable. 8,000 is our P value. And then E is a constant, so we'll use the E button on the calculator. But that E is raised to the 0.05 multiplied by 6. Alright, so all of the math here on the right side we can do on the calculator. Let's use this one first. So we have 8,000, and then multiply that. You can use the times or just put the letter. So second ln, and then we're going to raise our ln to the, now on this calculator I don't have to use this power key, this exponent key, because as soon as you hit shift ln, that writes the E on our display, and then whatever comes after that is the exponent. So I need the exponent to be 0.05 times 6, and then close my parentheses and hit equals. Looks like we have $10,798 and 87 cents. The 0 is not enough power to make that go up, so 87 cents. Let me box that in. And we can use our other calculator and make sure that we know how to use this one. So again, on this one we have to work backwards. So we're going to do the exponent first. 0.05 times 6 equals. And then we're going to hit the E to the X button, which is the second, and then ln. So second ln, and we see that we have 1.34. And then multiply that by 8,000 and hit equals. So we have our 10,798.87.